These are some of the Sphericons I've designed and 3D printed, and they were all printed on a single colour 3D printer. I'm going to show you how. Hi, I'm Andy Wobbly. Welcome back to Make It Down to Earth. This is a Sphericon. It's a solid object that has some particularly interesting properties. Now, I could give you the formal definition, but to be honest, it's a bit dry and long-winded. So instead, here's my down-to-earth definition. Sphericons roll in a wibbly wobbly way. I got switched on to Sphericons a few months ago when Angus at Maker's Muse released his video. In there he talks all about Sphericons and shows us his 3D printed versions. Then a few weeks after that, Devon at Make Anything released his video showing us his awesome collection of Sphericons, which gave me a whole bunch of new ideas for things to try out. There are links to both those videos in the description below. Do check them out if you're interested in knowing more about Sphericons or getting some other great ideas. Sphericons are super simple to design for 3D printing. In fact, it takes less than a minute to design one in Fusion 360. No bamboozle, it really is that simple. I'm going to show you how. A basic Sphericon is created from a square profile, but there are all sorts of other kinds of Sphericons you can create from different shapes. So we'll then take a look at the different classes of Sphericons using some handy infographics I've created. Then the fun really begins when we start customizing the basic profile to come up with our own designs. So I'll take you through some of my Sphericons here and show you how I made them. And that will all be working up towards the stars of the show, which are these multicoloured Sphericons all printed on a single colour printer. I'm going to do another separate video where I concentrate on my experimentation with multicolour printing in detail, and I've also got another video planned where I'll be talking about the finishing techniques I use to get some of the lovely finishes on these Sphericons. And if that wasn't enough to get you rushing to hit that subscribe button, I've got a third video where I will talk about all the bases that I've got for my Sphericons, and that's a technique that you can apply to any model, not just Sphericons. All of my designs are open source. There's a link in the description to the GitHub repository where you can find the STL files so that you can print them out yourself. And there are also all the Fusion 360 files so that you can work through the examples in the video or use them as the basis for your own designs. But before we get into too much technical detail, let's take a closer look at what I've made. Let's look at the basic process for creating a Sphericon in Fusion 360. We're going to create the simplest Sphericon based on a square profile. Create a new sketch on the XY plane, then use the inscribed polygon tool, click on the origin for the centre, set the number of sides to 4 and the radius to whatever you like. Then hit L for the line tool and draw a line going horizontally across from one point to the other. That's the first step to define our base profile. Then we use the revolve tool, select one half of the profile and revolve it around that centre axis. This creates what's known as a bicone. Then we use the split body tool to split that into 2 halves across the XY plane. The final step is to hit M for the move tool and then rotate one of those bodies around the Z or Z axis if you prefer, going around 90 degrees. And there we have our basic Sphericon. The top and the bottom halves are both identical, so we just need to save the top half as an STL file. Then we can send it to our slicer and print out 2 copies of it on the printer. Once you've printed out the 2 halves, you need to fix them together somehow. For a permanent solution, you can use glue. Super glue or CA glue works quite well, but for a stronger bond, I think 2-part epoxy is a better solution. However, the real fun comes when you can rotate them. And for this, there is really no better solution than the one that Devon came up with, and that's to have the centre peg and a number of magnets arranged around the outside. And that gives a very, very satisfying action. I don't know if Devon has a name for this, but I find that centre peg with magnets arranged around the outside is a little bit clumsy, so I've just been calling this the Devonator. Let's create some holes for the centre peg and the magnets. So I'll create a new sketch on the XY plane, then draw a circle to, that looks about right. Then we can turn this off and set that to be a construction line by hitting X. So for the centre peg, I'm going to use an 8mm diameter hole and then offset that inwards by 0.3 to allow some clearance for the centre peg. Then my magnets are 5mm diameter, so I'm going to allow 0.3mm clearance, draw a circle there, and then use the circular pattern tool to replicate that 4 times around. So we can then turn the bodies back on. Just need to work on the top body, which we'll be printing. So the first thing I'm going to do is hit E to extrude, select each of these. Now my magnets are 3mm in depth, and I'm going to add on half the diameter of the hole, so that's 2.5mm, so that's 5.5, plus 0.5 for clearance, that's 6mm. Now the reason for adding on the extra bit is I'm then going to select the chamfer tool, select the bottom edges and put in half of the diameter, 2.5. And then I can do the same with the centre peg. So on the larger circle, so I'm going up 8 plus a half is 12, plus half 12.5, and then I'll chamfer that by 4mm. And the reason for doing that, let's just do a section analysis on the XZ plane. So that ensures that the top part of the holes isn't flat, but comes up at 45 degrees, so it's easy to print and doesn't require any support. So here's a simple square Sphericon. We can see the square profile on the inside there. It's revolved around to create the bicone, and here I've got some dark blue insets that create ring around each of the cones, and then when we give it the twist, they join up to create a single surface. and this explains why Sphericon rolls in a wibbly, wobbly way. So the top row of this diagram shows the process that we just followed to create a basic Sphericon, and we cut the profile from point to point. But we can also cut the profile from side to side. In this case, the intermediate form we get is a cylinder, and when we cut it and rotate it, we get a shape known as a dual Sphericon. Whereas the standard Sphericon has one surface and two edges, the dual Sphericon has the opposite, two surfaces and one edge. Now, a dual Sphericon doesn't roll in a wibbly wobbly way like a Sphericon does. In fact, it just kind of wobs and then stops, but they're still pretty cool. Instead of using a square as our base profile, we can use a hexagon. If we cut it from point to point, we end up with a hexasphericon that has one surface and two edges, or we can cut it from edge to edge and end up with a dual hexasphericon that has two surfaces and one edge. The only difference here is that the rotation we do at the end is now 60 degrees, which is 1/6 of 360. We can also use an octagon. If we cut it from point to point, we get an octasphericon, or if we cut it from edge to edge, we get a dual octasphericon. The additional difference here is that in the last rotation step, we've got two choices. We can rotate it through 45 or 90 degrees to get different forms. If you start with a polygon that has an odd number of sides, such as a pentagon with 5 or a heptagon with 7, then you have no choice but to cut it from point to an edge. So in this case, there's no Sphericon and dual, there's just one single object. But again, you have different possibilities about how many rotations you can make to get different forms. A great way to create variations on the basic profiles is to add something onto the corners. So here I've just drawn a circle onto one of the corners of the hexagon and then use the circular pattern to replicate it onto the others. When you come to revolve it, you can add those circles in to create a positive impression, or you can take them out to create a negative one where the circles are cutting into the main body. Now, you don't have to start with a regular polygon for your base profile. You can use almost anything if it has some degree of rotational symmetry. So for this one, I started with a single ellipse, then used the circular pattern tool to create 3 copies in total. I then revolved and rotated in the normal way to end up with a hexasphericon. This one uses the same principle, but instead of 3 ellipses, I have 5 and end up with a decasphericon. This is a hexasphericon nested inside another hexasphericon. The base profile starts off with a hexagon, and then I added a smaller hexagon onto each corner with the circular pattern tool. The outer loops are created by revolving the outer hexagons around the center axis, and the inner section is created by revolving the inner part of the hexagon with those outer hexagons removed. The inner part is revolved around an axis at 90 degrees to the outer part, so that they end up being at 90 degrees to each other. This is the yin-yang-icon, so called because it looks like the yin-yang symbol. The base profile was created as a 4-pointed star using some circles and straight lines. I then revolved it twice, once going point to point to create a sphericon, and the other time going from edge to edge to create a dual sphericon. So this is simultaneously both a sphericon and its dual. This one I call Strange Loops. It's not a sphericon, but it's created using the same basic technique. The base profile is hexagonal, and there are smaller hexagons around the outside with arms going in towards the centre. There are 2 sets of 3 interlocking rings. The outer rings shown in yellow are created by revolving a single hexagon around the centre axis. That's repeated 3 times going around the hexagon. The smaller rings shown here in blue are created by revolving one of those hexagons around a centre line so they come in to join in the middle of the larger hexagon. This was my first attempt at creating a multicoloured Sphericon that I could print on my single colour printer. It's created from two distinct pieces. There's a larger part and then a smaller inset which fits into that. That's glued into place, and then two halves are glued together to create half of the Hexasphericon. I took a slightly different approach for this Decasphericon. I divided the profile into vertical columns, which then when revolved created separate strips of colour. These were then joined together with 3D printed plastic pegs. Things really started to come together nicely, if you'll pardon the pun, with this design. It's created from just 4 identical parts, 2 in red, 2 in green. A red and a green piece are then rotated around the centre axis to lock them together, and then the 2 halves are connected together again with a peg and magnets. The same interlocking design was used for this. The only difference here is the shape of the outer profile. I'll be doing another video soon where I go into greater detail about the design process for these and other multicoloured prints that you can print on a single colour printer. So that's it for this video. Thanks for watching, and a big thanks to Angus and Devon for inspiring me to get designing and printing Sphericons. Don't forget, I've got other videos coming up on the multicoloured prints, on my finishing techniques and also the bases. But the next video will be about another solid object closely related to the Sphericon, the oloid. I hope you'll join me for that. I'm Andy Wardley, you've been watching Make It Down to Earth.